Thank you, Terry. Well, thank you for taking the time to attend tonight's presentation. Tonight, I'm going to fill your mind with some spectacular images and discoveries from the Saturn mission, the Cassini-Huygens mission to Saturn. I'm part of the JPL Solar System Ambassador Program. There's about 500 of us across the country, and it's a volunteer program where we give talks to our local communities. I think the only requirements to be a JPL Solar System Ambassador is a desire to learn and an interest in space. And if you're interested in learning more about the Ambassador Program, get with me after the program tonight and we can talk. With the help of JPL, I've trained myself on the Cassini-Huygens mission to Saturn, and I'm excited about sharing with you what I've learned about the mission. JPL is located, a little bit of background information, JPL is located in Pasadena, California. It's the lead research and design center for NASA, and it's an operating extension of the California Institute of Technology, or Caltech. Here's where we're going. First, I'm going to talk about the spacecraft, the creation, the launch, and the journey to Saturn. Then I'll talk about this probe that was let go of the Cassini spacecraft and landed on the surface of the giant moon Titan. Then we'll back away from Titan and we'll take a look at the planet, the rings, moons, and some of the more recent discoveries. I want to mention that I think it works best if it's an interactive presentation, so if you have some questions during the presentation, I can take some along the way. All right, I'd like to start with a little bit of background information on the two astronomers this mission's named after, namely Cassini and Huygens. And sometimes I like to think to myself, or imagine to myself, what if these two guys were in the audience tonight seeing the data for the first time? Could they have imagined the complex discoveries that have been made, or even the beauty of some of the discoveries that have been made so far? This is Christian Huygens. He discovered Titan, as well as a hairstyle that became extremely popular for rock bands in the 1980s. In 1655, with a homemade telescope, he discovered Titan. And interestingly enough, he stopped his search for other solar system bodies with the discovery of Titan because he was a follower of numerology and believed that our solar system was complete. There's something like 40 or 60 moons now discovered in Saturn's system. This is Cassini. He also had that 17th century rock star look going as well. He discovered the Cassini division. That's the large gap in the rings I'll go over in a couple minutes. He also discovered a number of moons, including Iapetus. And Iapetus is a really bizarre world. Half of this moon is as black as tar, and the other half is as light as freshly fallen snow. And this thing would actually disappear from sight during his observations. And back in the day, he actually correctly speculated that the reason it might be disappearing from sight was that it was turning its very dark face towards Earth. This is a really nice close-up of the Cassini spacecraft. Let me know if I'm blocking your view. We're gonna cut the lights when we go into space in just a couple slides. Good thought, excellent thought. This is the Cassini spacecraft. This is the Huygens probe. This is what was detached from the Cassini spacecraft and landed on the planet of the moon Titan. And you can get a really nice idea of scale here. Here's some guys here working in clean suits. And here's a really nice close-up of the Huygens probe itself. You can see here it's being fitted with that amber Kapton insulation material. The spacecraft itself has two engines, primary and secondary. It has three radioisotopic thermoelectric generators for power. Here on the back side of this is the Huygens probe. A number of instruments in the midsection, high gain antenna, and the long magnometer boom. And that's all the way out to 11 meters because the instrument that makes magnetic field measurements has to be very far away from the spacecraft. To facilitate communication with Earth, Cassini uses transponders, and the transponders have worked flawlessly throughout the mission. The transponders were built by Motorola. So let me repeat, the Motorola transponders have worked flawlessly throughout the entire mission. Please buy Motorola cell phones. By the way, I work for Motorola. All right, this is the Cassini launch vehicle. Cassini is up in this fairing here. You can think of it as about the size of a small bus. It's 12,000 pounds with fuel and about half that dry. All right, Terry, we're going. All right, so this is launch. It was launched in 1997. It was 2.2 million pounds from a dead lift. So you can imagine, I've been out to Wisconsin to see some amateur rockets, which are just spectacular to be next to or be close to. I mean, I couldn't imagine what this is like. Must have really been something. And this is a really nice image, delayed exposure image. This is a boat off Cape Canaveral, I think of Coast Guard. And I really like this image because there's this reflection off of the water is really gorgeous. All right, so in order to get to Saturn, Cassini really couldn't make a direct shot right there. It would have had to carry an enormous amount of fuel, and it would have never gotten off the Earth, out of the Earth's gravity if it had to carry that much fuel. So it kind of has to go the long way. And it uses this concept you may have heard of called gravity assist, or energy exchange with other planets. So Cassini was launched here in 1997, did about a half a lap around the sun, and flew by Venus. Used Venus's gravity to speed it up, came around, did another lap, swung by Venus again, swung by Earth, did another exchange with Jupiter, and ultimately arrived at Saturn in 2004. And this whole mission, 3 billion miles in 7 years. On its way past Jupiter, it checked out its imaging equipment, and it took this gorgeous shot of Jupiter. This is the moon Io. This is the one you may have heard of. It's got the, at any point in time, thousands of active volcanoes, and it's spewing out every second a metric ton of material. And the mission that I think, the New Horizons mission, which is a spacecraft on the way to Pluto, actually just took some images, you can find them on the web, of the volcanoes actually in action. The Cassini is an orbiter, so unlike the Voyager spacecraft that had flown by Saturn in the 70s and early 80s, Cassini is an orbiter. It's been there 3 years, and it's going to be there another year. And there are talks of planning for an extended mission. I'd like you to look at and understand that Cassini's not making one perfect, circular orbits around Saturn. It's actually changing its orientation and its inclination all the time, making different observations of moons and the ring. So this is a nice kind of top-down, looking from the North Pole, and you can see the orientation of all these various swing-bys of different moons and planets, or excuse me, different moons. And this is an edge-on view. So you can see that Cassini actually, has a very high inclination, making measurements of the poles of Saturn. All right, this is a really nice Saturn road map. This is where we're going to go first. I'm going to take it to Titan first because that's where the Huygens probe landed on the surface of Titan. But you can see in the Saturn system itself, you've got the rings, you've got a lot of moons actually in the rings, and you've got moons out here. When the Cassini spacecraft came into orbit, it flew through this part right here, as well as the Voyager and Pioneer spacecraft. This is a very sparsely populated area of the rings, and Cassini actually turned its high-gain antenna in the direction of flight during that time, just in case to protect the spacecraft. All right, so here's where we're going to go first. We're going to go to Titan. And ever since literally Huygens discovered it, it's been hidden from view. And the reason for that is that ultraviolet light breaks up the methane in Titan, and it creates this haze layer that we can't see through. So this has been shrouded in mystery ever since discovery. For comparison, Titan, I would like to compare Titan to some of our other planets and moons. So compared to Mercury, is Mercury still a planet? Yes, all right, it made the cut, terrific. So Titan's actually larger than Mercury. This is Venus for comparison. This is our home, and this is Mars. So Titan's a little bit smaller than Mars. Compared to moons, here's our moon, here's Io. That's the moon that was in that Jupiter image. This is Europa. You may have heard of this moon. This is the moon that's completely encased in an ice shell, and there's a liquid saltwater ocean underneath. I was actually at JPL, and I saw an exhibit describing possible mission down to Europa, where they're actually thinking about landing a probe or a lander on the surface of Europa, somehow melting through the ice, and then sending a swimming, aquabotic or aquanaut robot into this liquid ocean. Really, really amazing. This is Ganymede. This is the largest moon in our solar system, and this is Callisto. So Titan ends up being a little bit smaller than Ganymede. All right, so there's three things I'd like you to think about or remember about Titan and its unique atmosphere. First is that Titan has a very thick atmosphere, which is very rare for a moon. It's mostly nitrogen, some methane. Second thing I'd like you to remember is that even though it's about 40% the diameter of Earth, Titan's atmosphere extends 5 to 7 times higher than Earth's atmosphere, literally out to 250 miles. Third thing is that methane can be a liquid at Titan's surface temperature. So methane exists at a triple point. You can think of water or H2O on Earth exists in all three phases, water, liquid, solid, and gas. At Titan's temperature, methane exists at the triple point, all three phases. Here's what scientists thought they might find. Rivers, volcanoes, lakes, clouds raining out particulate. This should look strangely familiar, meaning the geological processes very similar to Earth, except the chemistry completely different. All right, how do we find out what's down there through that haze? First way is through the Cassini-Huygens subsystem. That has a special filter, and that detects wavelengths at 0.93 microns, which is just a little bit longer than human optics, and that makes the haze particles transparent. The second is radar. So smooth areas are going to bounce the radar away, and rough surfaces with lots and lots of facets are going to bounce some of that radar back, and that's going to create light features. The third way, maybe the most exciting way, is to the Huygens probe, which is just send the probe down there and take pictures the whole way. All right, so this is our first look using those filters I just mentioned. This is Titan. This is what it would look like if you were flying by in a spacecraft. And this is using the first, those filters I described. And this is our first look at the difference in surface composition of the surface. And here's kind of a really nice composite view of Titan. You can see that there's this certainly a contrast of material. You have some light features here. Again, there's certainly two different types of terrain, dark and light. If you're into conspiracy theories, this is an alien base NASA's hiding from us. I'm going to foolishly go with their story that it wasn't mapped at this point. All right, the second way to see what's down there, as I mentioned, is radar. And what radar found was evidence of cryovolcanism or ice volcanoes. Ammonia, there's evidence from other instruments that there's ammonia on Titan. And ammonia lowers the melting point of water by about 100 degrees Celsius, turning water into this highly viscous kind of gooey substance. And radar found, and when scientists studied and looked at these flows, it looked very similar to the kind of flows of lava on Earth. So this was further evidence that there's ice volcanoes on Titan. Another thing, Very few impacts. And whenever you find very few impacts, that suggests geologically active surface. Some process is altering and renewing the surface. Another thing that was found in radar is dunes. Vast expanses of dunes. Very similar to some of the kinds of dunes found on Earth. All right, the third way, maybe the most exciting way, is to get down under there, take pictures, and land on the surface. All right, so the probe came in at about Mach 20, so it was moving pretty good. First deployed this pilot chute at about 105 miles. The front shield was separated. Then at about 25 miles, the science chute, or the stabilizer parachute, was deployed, floated down, took pictures, and made some measurements on the surface. So this is obviously an artist's rendering of what happened. You can see the Cassini spacecraft here in the background. Huygens probe is floating down to the surface. You can see Saturn here. The Huygens probe is transmitting all the data back to the mothership, Cassini, and Cassini sending that back to Earth. Took about 2.5-hour descent, and also took about 80 minutes of data down on the surface. During the time, it was swinging back and forth, 60 degrees, withstanding winds of up to 250 miles. Just for reference, Huygens landed in this horseshoe-looking feature here. And this is one of the more spectacular images it took. What do you guys see here? Any?
A highway over there.
Highway? Anything else?
The alien base.
Alien base? Anything else? Bunch of mountains. I see Titan lakeshore property. So certainly something, very, very dark here, and lots of channels. The surface the sky was orange with patches of ground fog. The surface had the consistency of wet sand. These pebbles here, they're about fist-sized. They're not silicate rocks. They're ice, and of course, at Titan's temperature, they're absolutely rock hard. Now, this is a more recent radar image, color-enhanced radar image of a northern area, North Pole area of Titan. And what they found in this radar swath is evidence of 75 lakes ranging from 2 to 43 miles. This is the front cover of Nature magazine from a little less than a year ago. And the largest lake so far, methane-ethane lake they've found so far, is, just for comparison, to Lake Superior. This is about 39,000 miles, and Lake Superior 32,000. All right, I'd like to complete and wrap up the Titan section with a comparison of Titan to Earth. So the atmosphere of Earth, mostly nitrogen. On Titan, mostly nitrogen. The erosion agents on Earth, water, wind. On Titan, liquid methane and wind. Surface materials on Earth, silicate rocks and soil. Titan, water, ice rocks, and hydrocarbon. Volcanic agent on Earth is lava. On Titan, likely ammonia water. Vehicle on Earth, hydrocarbons in the tank, as we all know, and oxygen from the atmosphere. If you drive a car on Titan, you use hydrocarbons from the atmosphere and oxygen in the tank. So very similar geological processes, yet the chemistry completely different. And why don't we take a little journey down to the surface of Titan?
Now it is time for Cassini's piggybacking Huygens probe to take center stage. The product of the European Space Agency, Huygens' mission is to detach from Cassini, descend into the atmosphere of Saturn's largest satellite, Titan, and actually land on its surface. A final systems check, and then encounters Titan's upper atmosphere, a wake-up call sounds, and Huygens' array of instruments come alive. Larger than the planets Mercury and Pluto, Titan is one of the most intriguing satellites in the solar system. It has a substantial atmosphere, a thick, smoggy shroud of an atmosphere, rich in organic compounds that may hold secrets to the evolution of life on our planet. Batteries on board Huygens will power it for 3 hours, and enough to keep the probe sending back data throughout its descent, and as much as a half hour after it reaches Titan's mysterious surface. The descent phase has begun as Huygens slams into Titan's upper atmosphere at nearly 14,000 miles per hour. Over the next 3 minutes, temperatures immediately in front of Huygens' heat shield will soar from 300 degrees below zero to over 21,000 degrees Fahrenheit, twice the surface temperature of the Sun. In the same 3 minutes, atmospheric drag also breaks the probe's speed from nearly 14,000 miles per hour to less than 900. At 1.5 times the speed of sound, a pilot chute is released, pulling off Huygens' aft cover. Almost immediately, the probe's main parachute unfurls. We are 110 miles from the surface. Within 30 seconds, Huygens has slowed to little over half the speed of sound. The heat shield has done its work and is jettisoned. For the next 15 minutes, the probe descends under its main chute as initial scientific measurements begin. High above, Cassini collects the data transmitted by Huygens and stands ready to relay it to Earth. Finally, a smaller drogue chute takes over. Altitude, 85 miles. For the next 2.25 hours, as it continues its descent toward the surface, Huygens' instruments will be busy. They will sniff Titan's atmosphere, recording its chemical composition as well as make detailed measurements of temperature, pressure, and density. And onboard cameras will capture up to 1,100 pictures. Many scientists believe the chemistry of Titan's atmosphere mimics that of Earth long ago. If so, Titan may well provide scientists with the equivalent of a time machine to travel back to an era before life first developed on our world. Finally, the surface. Will Huygens discover multicolored dunes of hydrocarbon snows, lakes or seas of liquid ethane and methane, or an even more exotic world? Soon we will know, as Titan gives up its secrets.
Okay, that was Titan. Now let's take a look at Saturn itself, the rings, and a couple of moons. All right, back to our Saturn roadmap. Let's first take a look at Saturn itself. To give you an idea of scale, Saturn would fit kind of nicely between the Earth and the Moon, about 239,000 miles. Saturn's diameter is on the order of 74,000 miles. Now, end to end, these rings are on the order of 180,000 miles. But edge on, they are less than a half mile thick. So, 180,000 miles wide, less than a half mile thick. Kind of hard to get my brain around that one. Saturn is kind of sun-like in composition, mostly hydrogen, some helium. Cloud tops about minus 310 degrees Fahrenheit. Its day is 10 hours, and a lap around the sun is about 29 Earth years. Saturn does, by the way, have very fast winds. They blow easterly at greater than 1,000 miles an hour at the equator. And this structure here is actually a storm and you can see actually the winds cutting into the edge of the storm here. The white nature of the storm is from ammonia ice crystals in the upper atmosphere. This is a Voyager image of Saturn. This is one of my personal favorite Voyager images. Voyager was one of the spacecraft that visited Saturn and flew by before Cassini. And this one I like because it's the first time I was exposed to some of the more gorgeous ring effects and shadow effects. So Voyager is leaving Saturn. Voyager's on its way to the other gas giants to explore them. And the sun is over here, and so Saturn is casting a shadow on its own rings, and Voyager's kind of taking a last look, which I really like this shot. Since I mentioned the Voyager spacecraft, I want to remind everyone that they are still going. They're actively tracked every day. They're actually on a mission. They are on a mission to understand where our solar system actually ends and when true interstellar space begins. That's the point when the dominance of the solar wind and our sun on our solar system ends. Voyager 1 is about 9 billion miles from Earth, or about 2.5 times the distance from Pluto to the sun. This is a really nice image to illustrate just the paper-thin rings. So this is kind of an edge-on view, and you can see a couple moons here. Here's another gorgeous ring effect. The sun is down here. The sun is shining up through the rings, and you can see the image of the rings cast on the northern hemisphere. So just awesome. Yeah, I wish, could Cassini and Huygens have imagined that? I don't know. I don't want to underestimate them, but I think they'd be blown away. Saturn does emit radio signals or radio emissions, and they are rather intense. And what they did is they took them and they compressed them and they shifted them in frequency to make them audible. And they the sounds themselves come from radio emissions that are traveling down the magnetic field lines and interacting with the aurora. But anyway, they shifted these, compressed it so to make these audible, and they sound kind of cool. Okay, that was not the soundtrack of The Day the Earth Stood Still, although it certainly could pass as it. Another one of the ring phenomenon, which is really cool, is in this image the sun is down here, sun is shining up onto the rings, and the sunlight is reflecting back on the southern hemisphere. Call this ring shine and eliminating the southern hemisphere. Saturn does have lightning. It is about 1,000 times stronger than Earth lightning. The Cassini spacecraft did catch some lightning, not visibly, but did catch it with some other instruments, the radio and plasma wave science instrument. So again, Saturn's lightning about 1,000 times as strong as Earth's lightning. Certainly wouldn't want to be anywhere near it, obviously. The south pole of Saturn is its warmest point at about minus 188 Fahrenheit. And this is kind of a creepy, ominous image of the South Pole. I was watching a teleconference on this. This dark nature of this is, I saw one scientist speaking that they think it might be a chemical reaction or interaction of the chemistry of the southern pole's aurora. What they did find at the South Pole was something certainly they didn't expect. At the South Pole, there is a giant hurricane. It's 5,000 miles wide and 45 miles deep. If it was on Earth, it would be something like a Category 200 hurricane. That's at the South Pole, which was not expected. And at the North Pole, and this one really blows me away, there is a hexagon feature in the clouds. Now this particular image I'm showing here is in the infrared, which illustrates, which you can see some contrast a little bit better. But about 15,000 miles across in the clouds, there is a polar hexagon. Just amazing. And the hexagon rotates around at the with Saturn. All right, let's move away from Saturn. Let's take a look at the rings themselves. These are the rings in true color, quite gorgeous. They're named kind of weird. So this is the inner D ring, C, B. This is the Cassini division. This is the gap in the rings that Cassini first discovered. They now bear his name. The A ring and the Yankee division. Fun little fact, if you took all the ring particles together, it would be about 1/6 of our moon. Cassini did take this gorgeous image of the rings. This is, I guess, a Saturnian eclipse. So the sun is back here. And Cassini is in front of us here, and so Saturn is blocking out the sun. Anybody know what that little dot back there is? Oh. What was that? Anything else? No, it's not Titan. Any other guesses? It's Earth. All right. All right. Everyone, wave to the camera. The moons cause all kinds of perturbations and disturbances within the rings. And they have all kinds of influence on the rings. And this is a really nice image that illustrates some of those disturbances. So in this image, there's this little moon here. I think this is called Daphnis. And over time, it's cleared out its little space in the rings. And here is Saturn. So this material here, or this ring area here, is closer to Saturn, and this is farther away. And so when the ring particles get close to this moon, or the closest ring particles, they get attracted to it, they get disturbed. And so that's what's causing these sculptured, sculpted patterns in the rings. But you can see in the image that these scallops are ahead of the moon, and these are behind them. And what this illustrates is kind of one of the basics of orbital mechanics, that material or objects that are closer to the body it's going around are going to be moving faster. So this moon has disturbed these particles here, but since they're closer to Saturn, they're moving faster than the moon itself, so they've actually passed it up. Then these particles here are moving slower than the moon itself because they're farther away, so the moon has actually passed up its own disturbances. So there's actually 3 speeds, of course there's many more, but there's actually 3 illustrated speeds in this image, this being the fastest, this moon being the second fastest, and this being the slowest. And everything in this picture is moving from right to left. Is anybody with me? Yeah. Yes, all right. Staying on the subject of moon particle influence, the moons have eccentric orbits, meaning they're not perfectly circular, they're elongated, And so that causes these spiral density waves in the rings themselves, causing particles to combine together. And there's also bending waves. Because the orbits of the moons the inclination is off a little bit on some of the moons, it actually pulls some ring material north and south, creating these kind of bending waves. And this is a really kind of neat image, a close-up of the rings. You can just see the awesome complexity of the resonance impact of that these moons have on the ring particles. This is a nice little video of a ring plane crossing, and this is another one of those images that illustrates how thin these moons are, or excuse me, how thin the rings are. So Cassini here is in the South Pole, in the southern hemisphere, and there's a moon that just went flying by, and you can see as Cassini's going over the top, the rings almost disappear. Kind of neat.
Do you think Titan will be the future Earth?
The question is, do I think Titan will be the future Earth? I think Titan is probably too cold. It's minus 280 degrees, so I think that would be the first obstacle to overcome would be the temperature. This is actually a screenshot from the Cassini website. So if you click on any of these moons, you can get more fun facts, you can get more images. And let's take a look at a couple of moons in detail. Let's take a look at Mimas, Enceladus, and Iapetus. So the first two moons I'll talk about, Mimas and Enceladus, they're before Titan, or closer to Saturn than Titan. And let's take a look at Iapetus. That's the one that Cassini discovered, and that's actually farther away than Titan. Okay, so this is Mimas. This is the Death Star moon. So whatever hit this thing years ago, it must have been one heck of a explosion. I've heard scientists say that whatever hit this thing, if it was any bigger, Mimas would have been no more. This is the largest crater, I believe, in our solar system relative to the size of the body. This is Enceladus. This is a very bright moon. This is almost a near perfect reflector. It reflects something like nearly 100% of the light that's shown on it. Our moon, for example, reflects something like 10%. These are not alien snowmobile tracks. This is a close-up of all these fissures on this moon, and you can immediately see that this moon is very different than other moons in our solar system. Lots of fissures here, and you can kind of notice not very many craters. And whenever you see not very many craters, that typically means geologically active, something going on. And this was completely unexpected. Cassini was able to image another geologically active body in our solar system. This thing is spewing out water vapor. This thing is churning on the inside, and all those cracks and fissures are from eruptions from Enceladus spewing out water vapor. Completely unexpected to find another geologically active moon in our solar system. Oh, I snuck a Dione image in here too. This is Dione. This is just a pure beauty image. As you can tell, I'm very much addicted to images where the sun is down here, shining through the rings, and then casting up on the Saturn itself on the northern hemisphere. Just pure beauty. Okay, let's move past Titan. Let's take a look at Iapetus. All right, so this was the moon that Cassini discovered. One half of this thing as dark as asphalt. The other half as light as freshly fallen snow. And what they discovered was something just certainly unprecedented. Was there is a ridge on Iapetus that is exactly at the equator. And from what they've imaged in these images, 800 miles long and 8 miles high. These are some better close-ups of it. Again, 8 miles high, exactly at the equator, and from these images, 800 miles long. Just unbelievable. I don't know if you guys ever used, like, when I was a kid, I had these Play-Doh machines to make a ball or make a sphere. And you could press the Play-Doh down, and it would leave like a little seam on the outside. That's what I think of when I see Iapetus.
Question.
Yeah, go ahead.
How do they determine the equator on these moons?
The question is, how do they determine the equator of these moons? I think in this case it's in reference to it going around Saturn. So it's relative to the inclination of this orbit. So this moon its inclination is not very high. So it's relative to its axis of rotation. All right, the idea tonight was really to just whet your appetite. I think of this as our mission. We own these discoveries. It's our mission. So I encourage you to go to saturn.jpl.nasa.gov. There's literally new images every day. You can contact me by my email address. I've also got a bunch of handouts, a bunch of bookmarks. Please take whatever you'd like. I want to get in a little commercial. I'm a member of this group called Chicago Society for Space Studies. It's a fancy name for just a bunch of people just like to get together and go on field trips. We go to Adler, we go to Fermilab, we go to various astronomy clubs. So it's just a social club, a couple pamphlets on that. And if you happen to need a PDF of this presentation, you can download that from the web. So why don't we get the lights, Terry? Well, thank you for taking the time. Please grab bookmarks, whatever you need. Thank you. Oh.